All right, we're trying to decide if these are similar. If they are, we're going to give one of these three reasons, either angle, angle, side, or side, side, side. And then it may be the case that they are not similar or there's not enough information. We have two sides in each triangle, or two pairs of sides, and then a pair of angles, and it's the included angle. So we should be down to either side angle side or no. They're not similar or there's not enough information. So let's see if these sides are proportional. So you can figure out your scale factor by doing new over original. So new over original, these sides correspond to each other. And then see if this next one has that same thing, same scale factor. If you want to, you can simplify that. You divide them both by 2, you get 5/3. So the question is will 6 2/3 simplify, 6 2/3 over 4 simplify to 5/3? One way you can do that is you can just put it in your calculator. 6 fraction button 2 fraction button again. On most calculators, fraction button and mixed number button are the same. So 6 2/3 divided by 4, and you get 1 2/3. Now, if we change that to an improper fraction, you do get 5/3. So it may be a number of clicks on your calculator, but you should be getting 5/3. Another way would be to change this to an improper fraction. 6 times 3 is 18, plus the 2, 20. So 20 over 3 divided by 4. 4 is a fraction, 4 over 1. To divide fractions, you multiply by the reciprocal. So you can do 20/3 times 1/4. And so you get 20 over 12. Divide them both by 4. And guess what you get? 5/3. So since the ratio of this over this is equal to the ratio of this over this, then those sides are proportional. And we have the included angle, and so we can say that these are similar by side angle side. You got all three sides in both triangles, so let's compare the smallest sides. We've got 2 and 4. So as I go from the small one to the big one, I multiply by 2. So I have a scale factor if I'm going from letting the big one be the new one. The scale factor is, again, 4 over 2 or 2. So let's see if that holds true for all of them. In the small triangle, the middle side is 3. 3 times 2 is 6, so that works. And then let's try the biggest side in each triangle, 4 and 8. 4 times 2 is 8. So these are similar by side, side, side. We don't have any angles labeled as congruent or any angle measures given, so we can't deal with angles here. So these are similar by side, side, side. Got all three sides here in each triangle. Let's see if these are proportional. So new over original, if I let the one on the right be the new one, we'd have 4 over 5 for the biggest sides. Now it's a tie there, so you could write 4 over 5 twice. Let's see if that's equal to the smallest side on the one on the right over the small side on the other one, 2/3. Now, you can change them to decimals if you want to see if they're equal, 0.8 and 0.6 repeating. These are not equal. These sides are not proportional. So you should have been down to side, side, side just based on the given information, either side, side, side or no. And we include that these are not similar because the sides are not proportional. All right, here we've got vertical angles that are congruent, and then we've got parallel lines cut by transversals, so alternate interior angles are congruent. Once you get to two pairs of angles that are congruent, then you know that you have similar triangles by angle, angle. All right, it says which of these statements is not true. So the angles are easier to check for me. So Y matches up with B, confirm that that's true. A matches up with X. All right, confirm that those are true. Now the sides, they have to be proportional. So AB is to XY, those match up, as AC, first and third, is to XZ, first and third. All right, so those are good. Let's make sure that this last one's not correct. XY, first and second, is to AB, first and second. So that first fraction's good. That's equal to XZ, first and third, equal to BC, second and third. That is not a match. These fractions, these segments measures do not correspond to each other, so that is not always a true statement, given that we have those similar triangles. All right, goal here is to find the perimeter. Let's see, BC is 6. We've got all the given information filled in. So the perimeters will be proportional to the sides. They'll have the same. The perimeters will have the same scale factor, same ratio as the scale factors. So the perimeter of this one is easy enough to calculate since we have all three sides. 9 plus 11 is 20 plus 13 is 33. So perimeter of this one on the right is 33. I want to figure out the perimeter of this one. Now I know that this side is 11 and it corresponds to this one. I can double check up here in the similarity statement. So those do match up. So 11 is to 33. Well, the perimeter is 3 times this side length. It just happens to be that way in this triangle. So the perimeter over here, since it's similar, will have to be 3 times this side length. So 3 times 6 gives us 18 for this perimeter. Perimeters are proportional to the sides. All right, I'm looking for H. Angle H is what the X is. H matches up with angle D. I don't have angle D over here, but I know they're congruent because they are similar quadrilaterals. Similar figures will have angles that are proportional. Corresponding angles will be congruent, I should say. Angles that are congruent. Angles in a quadrilateral will add up to 360. You may remember drawing in a diagonal there. You see two triangles, so the total will be 180 in each. 180 plus 180, 360. So let's add the ones that we know. We know that we have an 85-degree angle, 95-degree angle, 120. So I'm getting 300. And so if the total is 360 and 3 of them add up to 300, then the remaining one is 60 degrees, of course. Let's see. All right, these triangles are similar. And so let's look at two sides that match up. AB and DE match up. So as you go from the smaller to the bigger, you multiply by 3. 3 times 3 is 9. So following that same scale factor, I'm looking for, let's see, CD here. So CD is this length. That corresponds to CD corresponds to BC. So if I multiply that by 3, 3 times 3, 3.5 times 3 is 10.5. And then it asks for CE. CE is this distance. So if I take this one and multiply by 3.5, It's multiplied by 3, excuse me. You get 11.1. Double check. 3.7 times 3 is 11.1, yes. All right. Quadrilateral ABCD is similar to, just write it in the way they correspond. Now I'm noticing all these are right angles. Also noticing that this side length AB is 1, GH is 2. Let's see if these are proportional. BC is 3, and HI is 1, 2, 3, 4, 5, 6. Okay, so we're good there. As we go from this one to this one, we multiply by 2. So these are similar. Now we'll name them in the way they correspond. G matches up with A, H matches up with B, and then I and J. So say these are similar because all the corresponding sides are proportional and the corresponding angles are congruent. Let's see. We've got two of the three angles in each of these. So let's make sure that we do in fact have two angles that are congruent. So add to them that you know, let's like on the one on the right, 67, 67. Add those together, you get 134. Subtract that from 180. And you get 46 degrees for this missing angle. So sure enough, we do have congruent triangles here. In fact, we have isosceles triangles. All right, so 20 is to 26 has 26 is to x. You can set up a proportion if you like, or you could figure out the scale factor, the one on the right over the one on the left maybe, if you're doing scale factor. Scale factor would be 26 over 20 if you do it that way. Divide that, you get 1.3, I believe. Yeah, so you get a scale factor of 1.3. As you go from the smaller one to the bigger one, you're multiplying by 1.3. That's how we're going from this. So we can do the same type of thing here, multiply by 1.3. So 26 times 1.3 gives us 33.8 for the x for the side length there. Some of you may set it up over a proportion and solve it that way. All right, this is a dilation with a scale factor of 3. If they don't tell you a center of dilation, it's at the origin. So we're going to multiply each of these coordinates by 3. So this 6 gets multiplied by 3 to give us 18. The 4 gets multiplied by 3 to give us 12. The 5 gets multiplied by 3 is 15, and 0 times 3 is 0. Negative 10 times 3, negative 30, and finally this negative 2 times 3, negative 6. When you do a dilation from the origin, you just multiply your coordinates by the scale factor. All right. If this is 14, this length is 14, and this is 8, then this missing one right here is 6. So we can say you have some flexibility here. You might say 8 is to 12 as 6 is to x. And some of you may solve that proportion. You can cross multiply, you get 8x equals 72, divided by 8. You get 9. Some of you may do a like kind of the scale factor idea. 12 divided by 8 gives you 1.5. So you'd be multiplying by 1.5 as you go from the smaller one to the bigger one. Similar to the idea of scale factor. But you should be getting 9. So if you did 6 times 1.5, that would work. All right, number 13. F and U correspond to each other. So angle U has to be 46. Let's see. Okay, we're asked for the scale factor. The new is going to be over the original. So we'll call the one on the right new, one on the left original. All right, so I would probably just take my smallest side and the one on the right, that's 4. Smallest side on the one on the left is 10. And simplify that, divide them both by 2, you get 2/5. Or some of you might write it as 0.4. Either one would be fine as a scale factor. All right, here we're looking for the measure of angle U. All the angles in a triangle add up to 180. So we can add 37 and 65, get 102. 180 minus 102 gives us 78. And you may have realized, hey, these are probably similar. All right, here we can set up a proportion as well. You can say 5 is to x as 4 is to 6. Some of you may think, okay, multiply by 1.5 from 4 to get to 6. And so you can follow that same pattern. Multiply by 1.5 here. And you get 7.5. So whether you solve a proportion or use kind of the scale factor type of idea, either one you should be getting 7.5. Sorry. All right, here 2 inches is to 6 miles, as 10 inches is to, we don't know that other value. So I'm thinking, okay, to go from 2 to 10, that's multiplying by 5. If I scale up by that same amount, 6 times 5 gives us 30, and that units there will be miles. All right, here we can say x is to 5 as x minus 6 is to 3. And there are several other proportions you could write. If you solve this by cross multiplying, 3 times x will be on one side. 5 times x minus 6, make sure you distribute that. You get 5x minus 30. And then a couple steps here to get rid of positive 5x, subtract 5x. So negative 2x equals negative 30, and then divide by negative 2. And so x is 15. Goal was to solve for x. We can plug that back in and make sure it makes sense. 15 here and 15 minus 6, 9 here. Each of these are 3 times the other one. Dilation by a scale factor of 1/2, and the center of dilation is at C. Okay, so we got our scale factor here of 1/2, the center of dilation at C. So C prime is going to be in the same spot. Now if I take this distance and half it, I'll get the new point. So that was 6, half that you get 3. So my new point there for A prime will be at 4, 1. And then you may have figured out these are right triangles, so if you want to use that idea, you can stop there and put B there, B prime, excuse me. You can also think about what this distance is and half that. All right, so hopefully you were able to follow that. You can, of course, go back to any of the problems that you need to see again.